Welcome to NCERT classes. Let's have an introduction to limits in this video. And this is meant for not only boards, class 11th and class 12th boards. It is also meant for who's preparing for the engineering entrance exams. Okay. So in NCERT, this is the 12th chapter in class 11th book. Okay, limits and derivatives. But in this video, we will limit our video up to limit section. Okay. The differentiation, derivatives, we will take up in next video. Okay. So what are the topics we'll cover? We'll cover the concepts of limits, LHL, RHL, left hand limit, right hand limit, methods of evaluating the limits, some standard limits, using limits using expansion series, basically algebraic equations, L-Hospital rule, and then exercise 12.1. Okay. So after this, there is a derivative section, but we will take up that in the next video. Uh, what is the where limits belongs to? Actually, limits belongs to a section of calculus in mathematics. Okay, and limits is the introduction for calculus. Okay, if you want to understand more calculus, you should understand the limits very well. Okay, then only you will understand the calculus. And what is calculus? Calculus deals with the change in the value of function as its variable change. When the variable of a function changes, how the change in the function result is happening, this is what calculus deals with. Okay, there are two major parts. One is differential calculus, the other one is integral. Differentiation and integration, we call it, right? So differential calculus deals with the rate of change of quantity. Integral calculus deals with the accumulation of quantity, sum of, basically. Okay. So the objective here is learn the intuitive idea of derivative and concepts of limit. Okay. You will understand the basics of calculus are derivatives and limits, so that you can actually start solving the problems using those principles. Okay. What is the idea of limit? Need to first to begin all the calculus or limits, we need to understand how the functions works. Okay. Let's say there is a function defined f of x equal to x square. Okay. You give values for x. Okay. And as you give the values, you get the value of f of x. Okay. So if you draw on a graph, you get on xy coordinate axis, you will get on y axis, you get the f of x value, and on the x axis, you get the inputs. On y-axis you get the outputs. Okay, so if you observe that graph, as x is getting close to 0, okay, as x is getting close to 0, the f of x also getting close to 0, right? Because the function is f of x is x square, so 0 square is 0. So if you take f of 3, it is 9, f of 2 is 4, f of 1 is 1, it is getting close to 0, right? F of 0.5 is 6.625. Okay. So, sorry, 0.25. Okay. And similarly, you will see f of 0 just before 0, you will see it is equal to, it's almost close to 0, not equal actually. Okay. So, we can represent this in this form, limit LIM, you will write, or LT, some people write. Okay. Limit x tends to 0, f of x, which is equal to 0. In this case, okay, this is the example. But general form is, as limit x tends to a, some value, integer, rational number, f of x is equal to L. Okay, this is what we give the general form of a limit. In this case, limit is defined. Sometimes you don't get any value for f of x when x is getting close to a. Okay, in that case, we say that limit is not defined for x as x is getting close to a. Okay, so the notation, this one, x arrow mark a, is always meaning we call x tends to a, but its meaning is x is getting close to a, not a, but it is close to a, either a minus, okay, little less than a, or a plus, little more than a. Okay, so consider the function g of x equal to absolute x. Okay, where x is not equal to 0. This function is defined only for non-zero integral values. Okay, or non-zero rational values. Okay, now g of 0 is not defined, but if you see the graph, okay, the graph looks something like this. Okay, there is a line coming at 45 degrees in the second quadrant, and at 45 degrees in the first quadrant here, right? So, but at 0 it is not defined. There is no value. There is no dark line, right? 0 is white. Okay, that white circle shows that it is not defined basically. A dark circle shows always it is defined. Now y equal to absolute x, which is or g of x, okay, where it is not meant for x of 0, looks something like this. But from the graph, you tell me what will be the value of f of the, g of 0, because you see from the left side, as it is coming close to 0, it is approaching 0 only, right? G of x is approaching 0. And as you check from the right side, as the right side it is approaching 0, this is also y values or g of x value is approaching 0. So from the graph, it is very clear and intuitively we can tell that, okay, f of 0 as x tends to 0, g of x is also 0, right? So this is what we will say that as the limit x tends to 0, g of x is tending to 0, or this is called the limit at x of 0 is 0. Okay, hope you understand this. Even though g of x is not defined at x equal to 0, we are telling as x is tending to 0, g of x is 0. But you have to remember one thing. Okay, whenever you are calculating limit value, you should check from both sides, left hand side, right hand side, and confirm that both sides it is matching, coming to the same point. If there are two different points, then we cannot tell which value is correct, right? G of 0 or g of a, whatever, we cannot tell. So the matching left hand side and right hand side, it should match and come to the same point. Then only the limit is defined. Okay, hope you understand this example and the graph. Okay, so let's see one more example. H of x equal to x square minus 4 by x minus 2. Okay, now if you see this clearly, previous slide we actually forced to tell x is not equal to 0, correct? X can be 0. If x is 0, g of x is 0, so it is obvious. Okay, anyway, if you remove this restriction, it is anyway 0. Okay, but let's look at this slide. Here, at x equal to 2, this function is not defined because it will become divided by 0, right? 0 by 0 form it will be. So the function is not defined for x equal to 2, but h of x is defined as x square minus 4 by x minus 2. Now, if you draw this graph, okay, it is a straight line, comes like this. Only thing is at 2 comma 0, when x is equal to 0, this is not defined. You see the white spot. Okay, there is a discontinuity. Correct? There is a discontinuity. It is not a continuous graph. It is a discontinued graph. So this is a good example to tell that at x equal to 2, this function is not defined. Okay. Now, if you want to say that what is the value of h of x when x is approaching 2? Okay, this is where you apply your limits and see from, let's say, this is the value, right? At x equal to 2, this is the value. Okay, intuitively looking at the graph, I can tell, okay, both sides it is coming to 4, so the value is 4, correct? If you go to the left hand side, okay, you come close to x equal to 2, okay, x equal to 2, close to x equal to 2, you are approaching this value 4. From RHS side also, if you are approaching x equal to 2, as x is tending to 2, you are approaching towards 4, right? Since both sides are coming and matching at the same point, okay, they are coming to the same point from both sides, we can tell limit x tends to 2, h of x equal to 4. Okay, so this is the understanding of limits. Okay, you have to check from LHL side, left hand limit, you have to check the right hand limit, and then conclude that if LHL and RHL are equating to same point, coming to the close to same point, then that is the value of the limit. Okay, hope you understand this example. Okay, okay, same one, another example. If in all these illustrations, basically when for f of x at x equal to a, okay, what is the value of f of x at the limit? It does not depend on what is the limit value, correct? Limit value need not depend on what is the value of the function at that point. Okay, function point at that may be different, but LHL and RHL are left hand limit and right hand limit are pointing to different value other than f of that value, f of a. Okay, so the function definition does not depend on what is your LHL and RHL values. It can be absolutely different. If you see this graphs, you will understand. Okay, uh, from LHL, if I see it is coming to this point here, okay, and RHL it is coming to different point and it is a dark circle, that means function is defined here, correct? Function value is here and my RHL is approaching to function value, but LHL is approaching to different value. So still we say that limit is not defined because LHL and RHL are pointing to different values. Okay, similar case here, LHL is, in this case, RHL is coming to the function value. Here, LHL is coming to the function value, and RHL is going to some different value. Still, limit is not defined. Okay, and here LHL is coming to one point, RHL is not defined exactly at that point, but even if you extend it, it is pointing to a different value. It is going to a different value, right? It is not merging with the same point here. So limit is not defined in all these three cases. Okay. So what is the important learning? We need to find out the left hand limit. You need to find the right hand limit and then decide what is the limit value. Okay. And function value does not matter in this case. Let's see some examples. Then we'll understand more. Okay. Let us understand left hand and right hand limits more clearly with this example. Okay. So let's say that the function f of x defined such that it is 1 if it is x is less than or equal to 0, and it is 2 if it is x is greater than 0. Okay. So if I draw the graph, it looks something like this. Okay. For x less than or equal to 0, it is 1. Okay. And at x equal to 0 also it is defined, it is 1. Okay. So you have a dark circle here. And when it is greater than x is greater than 1, it is 2. And at x equal to 1, it is not defined because it is defined at other yeah, in this line, right? So this is white circle, this is dark circle. Okay, f of 0 is defined here, okay, as 1. Okay, now if you want to see if the function is defined, limit is defined or not, you have function value directly, right? You have f of 0 already defined as 1. Okay, but it does not mean that limit is defined, because you actually at f of 0, okay, left hand limit, if you take LHL, okay, it's written like this: limit of x tends to 0 minus slightly less than 0, f of x is 1. Correct? LHL side it is 1. If it is less than 0, it is 1. If it is greater than 0, a right hand limit extends to 0 plus f of x is 2. So LHL and RHL are not equal, which means limit does not exist, even though function is defined. Function is defined at f of 0, but limit does not exist. Okay. So this is the important thing to understand about the LHL and RHL. Okay. Once you understand this clearly, most of the things are clear in limits. Okay. Only thing is you need to understand how to solve the limits problems. Okay. So let's take another example. You may not be always given a function definition. You may be given a table where the x values and the function values are defined. Okay, so if you see here, if you see here, whether we need to check if the find the limits of this function at x equal to 2, but x equal to 2 information is not given. Okay, it comes in between these two. But at 1.9 it is 5.7, 1.95 it is 5.885, and just slightly before 2 it is 5.997, and just more than 2 it is 6.003. Okay, so which means it is very clear that at x equal to 2 the value will be close to 6. Correct? So limit at x tends to 2, f of x is 6. That's the limit. Okay, because from LHL side, RHL side, we are coming close to 6. Okay, and if you draw the graph, you will understand very easily this one. Okay, so hope you understand this. And this illustration, I took it from the NCERT book only, straightforward, because you may not be always giving the function definition. You may be given a table like this. Okay, yeah, next. Yeah, let's understand this more actually with these examples. What are the all possible ways? Okay, now here you have f of x equal to m, f of x if x is less than a. Okay, and f of x equal to n if x is greater than a. Okay, and f of x is not defined at a. It is not defined at a. So that means you have two different LHL and RHL are two different values. Correct? A minus it is m, a plus is it is n. Both are not same. So limit at extends to a, f of x is not defined. Okay. So you may have another case like this. You have a different LHL, different RHL, and function is defined different from those two. Okay, in between. Still, since LHL is not equal to RHL, not equal to f of a, limit is not defined only. Okay, we will say. Now, this is the case. LHL and RHL are not equal, but LHL is equal to f of a. Correct? F of a equal to m, LHL is also m, RHL is n. Okay, so this is also function is limit is not defined at x tends to at x equal to a, because LHL and RHL are different. It is nothing to do with the function value. Okay, now this is function value is actually different. Function value at x equal to a is n, but f of x equal to m when x is not equal to a. So which means the line is like this. Only at x equal to a the value is m. Okay. Now in this case, LHL and RHL are coming close to M, correct? Coming close to M, even though function is defined as f of x, f of a equal to n, but limit extends to a, f of x is M. Hope you understand. This is the case you need to understand very well. Okay. If both are different, it is obviously we will tell that they are not merging. So limit is not defined. Both are not merging. All three are different. So limit is not defined. I mean, both two of them are different. So limit is not merging. But here both are merging, but function is actually defined at a different location. Correct? But still we are telling limit exists. Limit extends to a, f of x is m, not n. Even though function value x of f of a is actually n, but we say that limit value is m. Okay, so this is the most important thing to understand. Okay, so last one, you have LHL, RHL, and the function value. All three are merged, and its value is m. So this is the special case we call the limit is continuous in this case. Okay, limit exists. Limit exists at as the limit extends to a, f of x is m, and we call this a continuous limit at x equal to a. At x equal to a, the limit is continuous. We'll say. Okay, you will get more about these things in class 12th about the limit continuity. Okay, but as of now, you just know that that's enough. Yeah, next. Let's understand the algebra of limits, how the addition, subtraction, multiplication works here. It works very similar to the general algebra. Okay, addition, limit of sum equal to sum of limits means if limit extends to a, f of x plus g of x is nothing but you apply limit to the individual function. Okay, similarly subtraction, similarly product. Okay, multiplication, similarly division. Only thing is denominator should not be equal to 0, right? If it is 0, limit is undefined. Okay, and there is a special case where you have a constant multiplication with f of x, so you just take the constant out because the limit of constant is anyway constant only. Okay, you apply the limit to the function itself. Okay, now out of all this division will give us lot of options. Okay, there will be several paths on this division. Okay, so here you need to check the conditions of 0 by 0, infinity by 0, 0 by infinity, infinity by 0. All these conditions you have to check and see what we can do, right? So this is the quotient rule, division, right? Quotient rule. First thing what we will do is if f of x by g of x, where g of x is not equal to 0, then it is straightforward, correct? If the limit extends to a, f of x by g of x, and g of x is not equal to 0 as the limit extends to a, correct? Then you are applying limit to the individual one, and then f of a, g of a you will call. Because g of a is not equal to 0, you are okay here. This is fine. But if g of a is equal to 0, what you will do? If f of a is equal to 0, then what will happen is, that means x minus a is a factor of this f of x, this function, and f of x minus a is also a factor of this function. So you find out, remove the factors out, and then cancel numerator and denominator, you can cancel. So you will end up with k of x and m of x, different functions which are independent of x minus a term. Okay, then you solve this problem. Okay, so this is how you will do when you apply algebra on this division rules. Okay, so this is very simple. There are more ways to solve this f of x by g of x limits. Okay, we'll see as we go. Okay, so let's see some example. Let's say f of x equal to x square plus 1, g of x is x plus 2, and limit of x tends to 1, f of x by g of x. So if I substitute the value x equal to 1, denominator is not 0, I am getting 2 by 3 value, so limit is defined and the value is 2 by 3. Fine, this is straightforward. Okay, and in this case numerator is 0, denominator is not 0, so the limit defined and limit actual value is 0. Okay, so in this case x square plus 1 and g of x is x minus 1, uh, limit actually denominator becomes 0 if I substitute x equal to 1. So which means limit is not defined. Is it correct? Okay, no, this is what we need to apply our algebraic rules and then find out the limit. How do we do it? Let's say f of x equal to x square minus 1, g of x equal to x minus 1. If I directly apply limit extends to 1, I will get 0 by 0, correct? So always try to remove zeros of the polynomial from the denominator and numerator, of course. Okay, wherever it is 0, you remove that. Okay, so x square minus 1, I can write it as x minus 1 into x plus 1, and denominator is x minus 1, I will cancel it. So I am left with, this is f of x by g of x is nothing but x plus 1. So limit x tends to 1, x plus 1, which is 2. So limit is defined and its value is 2, not division of 0. Okay. Hope you understand how to solve limit problems of quotient rule. Okay. So this is the yeah, more examples. Limit x tends to 1, x minus 2 divided by x square minus x minus 1 by x cube minus 3x square plus 2x. If you apply this limit to each term here independently, then you cannot solve this problem. Why? Let's see. The first term is nothing but x by 2, x minus 2 divided by x into x minus 1 minus 1 by x into x minus 2 into x minus 1. If I individually solve this limit, then I cannot cancel this x minus 1 term because at x minus 1 limit is this value is 0, right? So denominator will become 0. There is nothing in the numerator to cancel here for me, correct? This is also if I independently solve, same thing, same problem. I cannot cancel it. So what to do in this case? Limit is undefined? No, first you solve it simple by simple fraction method. Okay, how do you solve the fractions? You take the LCM and then x minus 2 whole square minus 1. Okay, if I simplify this one, I get x square minus 4x plus 3. And then denominator is x into x minus 1 into x minus 2. And the numerator will become x minus 3 into x minus 1 divided by x into x minus 1 into x minus 2. Now I can cancel x minus 1 on both numerator and denominator. So I am left with limit x tends to 1, x minus 3 divided by x into x minus 2, which is nothing but 2. That's the answer. Okay. So hope you understand how to apply the algebraic tricks. Okay. All the possible things which you do in algebra, you can apply here. When you get a denominator 0, when the limit is undefined, you try to solve it in a different way. Okay. Apply all your algebra tricks and try to solve the fractions or whatever method, polynomial, quadratic. Okay. All the methods you can apply here. Okay. One more, some more standard formulas. Let's see. Limit x tends to a, x to the power of n minus a to the power of n divided by x minus a is equal to n into a to the power of n minus 1. Okay. So simple proof is here. You have to remember this is very important one. You will get definitely get at least 1 or 2 questions where you have to apply this one. Okay. So you have to remember this. Only thing is how to remember. I always say you solve it yourself actually. Okay. Find the proof of that one. That means you are going to remember that easily. Okay. So x to the power of n minus a to the power of n, I can write it as x minus a into x to the power of n minus 1 plus x to the power of n minus 2 up to x to the power of 0. Okay. Now my limit x tends to a becomes x to the x minus a into this part divided by x minus a. Correct. So x minus a, x minus a gets cancelled. Okay. I am left with only x to the power of n minus 1 plus a x to the power of n minus 2 up to a to the power of n minus 1 x to the power of 0. These are n terms. If I substitute a in this, it will become a to the power of n minus 1 n times plus addition n times, which is nothing but n into a to the power of n minus 1. Okay. So this is a simple proof for this, but very, very powerful formula in limits. 100% sure you will have to apply this in every competitive exam. So you have to remember this very well and apply it. Okay. How to apply it? Let's see a few examples and then see. Simple example here. Let the question be something like this. Limit extends to 1, x to the power of 15 minus 1 divided by x to the power of 10 minus 1. So what I will do is, this is not in the standard form which I am looking here, correct? So simply what I will do, I can divide both numerator and denominator with x minus 1 and then independently apply limit to the numerator and denominator and apply this formula. Okay. So the numerator will become 15 into 1 to the power of 14. Denominator will become 10 into 1 to the power of 9. So 15 by 10, which is 3 by 2. Okay. So another simple trick is, whenever you see question like this, okay, you don't need to do all this. You just take 15 by 10. Highest power of the top one, highest power of the, numerator, highest power of the denominator, you divide, you'll get. But anyway, best way is, yeah, you apply, then you will not go wrong. And it is not a very lengthy method. Okay. Both are almost similar. Okay. You will get in less than minute. Okay. Another thing is something like this. Limit extends to 0. Square root of x plus 1 minus 1 divided by x. Okay. If you look from the top, this does not look like this formula, right? But you can easily convert it. Let x plus 1 be y. Then what happens? This is x plus 1 tends to 1, correct? That means y tends to 1. Square root of y minus 1 divided by y minus 1. This is nothing but y to the power of half, 1 to the power of half. So this will become half into 1 to the power of half minus 1, which is minus half, correct? 1 to the power of anything is 1. So answer is 1 by 2. Okay. See, this is how you can apply this powerful formula. Okay. Okay. And we also have some trigonometric functions actually, limits of trigonometric functions. You normally you apply it straightforward. Wherever limit is extends to 0, sine of x is sine 0, which is 0, we know. Limit extends to 0, sine of x is cos 0, which is, sorry, cos of x is cos 0, which is 1. Similarly, you will apply for all others, but sometimes you get denominator 0, right? In that case, what to do? Okay. So there is one method which is we should know actually, sandwich method. It is a important algebraic method actually, which you apply here to find out some important limits. Okay. What this says is, let's say if f of x is g of x, okay, then limit extends to a, f of x also less than or equal to limit extends to a, g of x. Means if the functions are in a inequality relation, the inequality relation holds when you apply limit also. Okay, that's what this says. So, and those two curves, two functions can be anything like this. They can come very close, but it will, g of x will never cross, f of x will never cross g of x value. Okay, it will be always less than or equal to. That's it. Okay, it will never cross. This is how this is. Okay, so now let's take what is sandwich theorem. Sandwich theorem says, let's say you have three functions, f of x less than or equal to g of x less than or equal to h of x. Okay, that's what is written here. Now, you tell me what will be the g of x value if both f of x and h of x are equal. This also has to be same, because this is in between these two. If these two are equal, this also has to be same as this, correct? So that is exactly what we are going to use here. For sum a, limit extends to a, f of x equal to limit extends to a, g of x. F of x and g of x are equal, which is, let's say, L value. It means limit extends to a, h of x also equal to L. Okay, because it is sandwiched right between these two. It cannot be, it has to be in between these two. So it cannot go more than that, it cannot go less than that, right? It has to be equal. That's the only option. If first and second are equal, then middle one has to be equal to these two. It's very simple to understand, right? So what is the advantage of this one? Based on this, we can actually apply the sandwich theorem and find out a lot of trigonometric limits actually. Okay, one of the most important one is here. Limit extends to 0, sine of x by x. Okay, so if you see here, denominator has a x 0, right? Division by 0. Now we cannot apply any of the algebraic methods here to cancel the x, right? Because numerator is sine x, there is nothing else is there. So what to do now? Okay, so this is where our sandwich theorem is useful. Okay, so in trigonometry, you have a relation. Okay, cos of x is less than sin of x by x less than 1, less than or equal to actually. Okay, cos of x is less than or equal to sin of x by x less than or equal to 1. Okay, once you know this important relation, okay, you can apply limits on this relation. Okay, limit x tends to 0, cos of x less than or equal to, correct, limit x tends to 0, cos of x will be 1, limit x tends to 0, 1 is 1. So you are getting the first one and third one both are equal at x tends to 0. When x is nearing 0, cos x is equal to 1, which these two are equal. That means sin x by x also should be equal to 1. Right? There is no other option because you just now we understood the sandwich theorem, right? So from sandwich theorem, we can say that limit x tends to 0, sin x by x equal to 1. Okay, so this is a very, very important trigonometric ratio to remember. Based on this also, just like I told you just before, algebraic formula 1, right? X to the power of n minus a to the power of n by x minus a. This is also almost equivalent to that. You will definitely get at least one question based on this. Okay. Okay, we'll solve some of the questions based on that. Let's take question is limit x tends to 0, 1 minus cos x by x. Okay, so we know that 1 minus cos x, I can write it as 2 sin square x by 2. Correct? 2 sin square x by 2 by x. Now I will write it as sin square x by 2 by x by 2. Okay, divided by x by 2. Okay, now I know that limit x tends to 0, sin of x by x is 1. So this is nothing but sin of x by 2 divided by x by 2 into sin of x by 2. So this is 1. Limit x tends to 0, this value is 1. I know, right? So 1 into 0, which is 0. Okay. So this is limit is defined. Limit is not undefined. That is important. 0 does not mean that no value for limit. Okay. 0 means there is a 0 value for limit. Okay. Undefined is different. Undefined is you cannot solve that. Okay. Limit is not defined at that point. Okay. Similarly, limit x tends to 0, sin 4x by sin 2x. Okay, sin 4x I can write it as 2 sin 2x cos 2x. Okay, and denominator is sin 2x. So I can cancel sin 2x and 2x. So sorry, there is equal to missing here, which is equal to 2 cos 2x. So limit x tends to 0, sin 4x by sin 2x is nothing but limit x tends to 0, 2 cos 2x, which is 2. That's the value. So you can apply all your trigonometric fundamentals into this one to make sure that there is no 0 on the denominator. Okay, at that limit. Okay, now another most important and one of the excellent rule, L'Hospital rule it's called. Okay, so using this actually you can solve the limits problems very, very quickly. Okay, only thing is you should know when to apply this. That is most important. Okay, let's say limit x tends to c f of x and limit which is equal to limit x tends to c g of x which is equal to 0. That means if you are applying limit on the f of x by g of x, then I am getting 0 by 0 or infinity by infinity, something like that, right? In that case, I can apply limit on the first derivation of numerator and denominator. Okay. If here also you get 0 by 0 or infinity by infinity, you can actually repeat the step and apply on the second derivative, provided you don't get 0 on the denominator. Okay. So let's see this, how to apply, how to use it. Okay, what it says is L'Hospital rule is a powerful tool in calculus for finding limits that result in the indeterminate forms, which is like 0 by 0, infinity by infinity, like that. Okay, now limit x tends to a f of x by g of x equal to 0 by 0 or infinity by infinity, then limit can be obtained by limit x tends to a f dash x, that is first derivation divided by g dash x, first derivation of g of x. Or if here also if it is 0 by 0 infinity by infinity indeterminate, you can actually apply second derivation and go on. Okay, and after normally after second derivation you will know it will be determined or not. Okay, so only thing is condition is first you try your algebraic methods to resolve the limits first. If you really cannot solve that, and then you come to this and do a derivation. Okay, and it should be in this form. You don't apply wherever you want. Okay, example, same sin x by x we solved before, right? Now, if I apply L'Hospital rule, numerator will become derivation of differentiation of sin of x is cos x, differentiation of dx by dx is 1. So, this is nothing but as simple as limit x tends to 0 cos of x, which is cos 0, that is 1. So, very simple, right? You don't need to understand the sandwich theorem. Okay, but that is a very useful theorem. You have to know. Okay, let's see another one. 3x square limit extends to infinity. 3x square plus 2 divided by 5x square minus 4x. Now, in this case also, you have nothing to cancel here. There is you cannot really do apply any algebraic method to cancel the infinity term, right? Because x is tending to infinity here. Both numerator and denominator are infinity, correct? So one way you can do is you divide this with in algebraic method. You what you do is you divide the numerator and denominator with x square, right? Then it will become 3 plus 2 by x square, 5 minus 4 by x. Okay, 2 by x square, 4 by x are zeros, right? Because it is x is tending to infinity, 1 by x will be a 0, right? So you will be left with 3 by 5. That's the answer. Okay, now if I apply L'Hospital rule, it is very simple. Limit x tends to 0. First derivation of this one is 3 times 2x, 6x that is, divided by 5 times 2x minus, sorry, this is not 1, this is 4, minus 4. Okay, now if I apply L'Hospital rule here, again still x term is there, so infinity and infinity you will get infinity. So you apply again, okay. So differentiate again numerator and denominator. What I will get is 2 into 3, which is 6, divided by 5 into 2. This will become 0, right? So the answer is 3 by 5, which is what 3 by 5 here, right? You take the highest uh, power term and then both numerator and denominator, the quotient is enough actually, if both are equal, okay. So this is another way of solving the limits. Very, very powerful tool, L'Hospital rule. Remember it. This is not there in the NCERT book, but I think without this, you cannot solve any of the engineering entrance limits questions. Okay. Okay, another one. Limit extends to infinity. 3x square plus 2 divided by 5x square minus 4x. I think it's same. Okay, I'm just showing the other way to solve it. Okay, this is what I explained. Divide a numerator and denominator with x square. So you will get 3 plus 2 by x square divided by 5 minus 4 by x. Okay, now since x is tending to infinity, 1 by x square will be 0. So this term is 0, this term is 0. So it is 3 by 5. Okay, so know these tricks because you don't know when, what, which trick you are going to apply, right? So you have to know all these tricks. Okay, all these methods of solving limits problems. Okay. Yeah, let's do the exercise 12.1 now. This exercise is specifically for limits only, okay, because we haven't started the derivatives part of the chapter yet. And as I said before, derivatives part we'll cover in next video. Okay, this is very simple. Limit x tends to 3, x plus 3. You just substitute the value, you will get 6. Okay, this is also similar. You just substitute the pi value. Okay, and don't say pi minus 22 by 7 equal to 0. Okay, this is not actually. Okay, 22 by 7 is only approximation. Okay, pi is not exactly 22 by 7. So just keep the answer like that. Okay, next. Limit r tends to 1 by r square, which is nothing but pi. Yeah, limit x tends to 4, 4x plus 3 by x minus 2. If you substitute, you are not going to get any zeros in the denominator. So you can substitute directly 19 by 2. Okay. Similarly here be careful, x is tending to minus 1, okay, not 1, okay. Since it is minus 1, denominator is not going to be 0, so you just substitute the value, you will get minus half. Okay, x tends to 0, limit x tends to 0, x plus 5, x plus 1 whole to the power of 5 minus 1 divided by x. Okay, so yeah, here uh, you can apply the x to the power of n, that formula, x to the power of n minus a to the power of n by x minus a. So I will write it in that format. It will become x plus 1 whole to the power of 5 minus 1 divided by x plus 1 minus 1. I will write x as x plus 1 minus 1. Okay, which means if I apply the limit, it will become 5 times x plus 1 whole to the power of 4. Okay, or x equal to 0 basically. So that is 5. X plus 1 tends to 0 then, right? So x plus 1 tends to 1. So which means 5 times 1 to the power of 4, which is 1. So answer is 5. Okay, next. Limit x tends to 2, 3x square minus x minus 10 divided by x square minus 4. Okay, so here if you if you put 2 in x, basically denominator you will get 0. Okay, so you have to remove the x minus 2 term from the numerator and denominator. So factorize them. If you factorize and cancel x minus 2 from both numerator and denominator, this is nothing but limit x tends to 2, 3x plus 5 divided by x plus 2. Now you substitute the value x equal to 2, you get the answer which is 11 by 4. Okay, next limit x tends to 3, x to the power of 4 minus 81 divided by 2x square minus 5x minus 3. Okay, so here I can write this expression x to the power of 4 minus 81 by 2x square minus 5x minus 3 as x to the power of 4 minus 3 to the power of 4 divided by x minus 3 into 2x plus 1. So I will separate the limits because I can apply limits on the product of the multiplication also, right? Multiplicative functions. So I will apply limit separately. Limit x tends to 3, x to the power of 4 minus 3 to the power of 4 divided by x minus 3, and limit x tends to 3, 1 by 2x plus 1. Correct? So here I apply this limit theorem formula, x to the power of n minus a to the power of n by x minus a, which is n into n minus 1. So if I apply that, I get here 4 into 3 to the power of 4 minus 1, which is 3, into here I substitute 3 here, 1 by 7. So that is nothing but 108 by 7. That's the answer. Because this is how you have to use this formula. Okay, so it may not be straightforward formula application question you will get. You have to tweak and then see where I can apply which formula. Okay, yeah, this is 10th. I think ninth will go. Limit is z tends to 1, z to the power of 1 by 3 minus 1 divided by z to the power of 1 by 6 minus 1. So as I said, you can divide both numerator and denominator with z minus 1. Okay, and apply the same formula. So it will become 1 by 3 into z to the power of 1 by 3 minus 1, and denominator is 1 by 6 into z to the power of 1 by 6 minus 1. Correct? Z is nothing but a. Sorry, z is nothing but 1. So if I substitute 1, I get 1 by 3 by 1 by 6, which is nothing but 2. Okay, ninth one is limit extends to 0, ax plus b divided by cx plus 1. If I substitute 0 here, okay, there is no denominator 0 here. So it will become b minus 1, which is b. Yeah, limit extends to 1, ax square plus bx plus c divided by cx square plus bx plus a. A plus b plus c is not equal to 0. So if I substitute x here, I get numerator also a plus b plus c, denominator also a plus b plus c. Since they are not zeros, I can cancel them. 1 is the answer. Okay, limit extends to minus 2, 1 by x plus 1 by 2 divided by x plus 2. Okay, so here if I put minus 2, denominator will become 0. Okay, so what I will do is I will first simplify the numerator. 1 by x plus 1 by 2 is nothing but x plus 2 by 2, 2x. Now I can cancel my x by 2, x plus 2 in both numerator and denominator. I am left with limit extends to minus 2, 1 by 2x. So this is nothing but minus 1 by 4. Okay, next. Limit extends to 0, sine ax by bx. Okay, so we know that sine x by x is basically limit extends to 0, sine x by x is 1. So I will write in that format. How can I do that? Sine ax is there in the numerator, so I add ax in the denominator, and b is already there, and to cancel this here I added a in the numerator. Right, now this will become a by b into sine ax by ax, and x tends to 0, ax also tends to 0. Correct? So this equation is nothing but this is 1, this is a by b, so I am left with a by b. That's the answer. Limit extends to 0, sine ax by bx, which is similar to the last problem. You just add numerator divide with ax, denominator divide with bx, and then since you are ax by bx, you are 1 by ax into 1 by divided by 1 by bx you are adding, so a by b to nullify that, right? So answer is a by b here. Okay, do it carefully. I think these are all easy problems just for your practice actually. For engineering entrance exams, you will definitely get more complex problems, but without solving this, you will not enter into complex problems. Please don't do that actually. Then it will only become remembering the problems rather than solving the problems. So you have to solve all the easy problems, all the methods, control over those methods, then go to the complex problems. So limit extends to pi, sine of pi minus x divided by pi minus pi minus x. Okay, this here if I can easily write, if x tends to pi, then pi minus x tends to 0, correct? Then this becomes my sin x by x format. Okay, and this is a constant anyway, so I'll leave it like this. So this is 1, this is 1 by pi, which is 1 by pi is my answer. Okay, limit extends to 0, cos x by pi minus x. Okay, I can substitute 0 here, x equal to 0, cos 0 is 1 divided by pi. Then limit extends to 0, cos 2x minus 1 by cos x. Uh, yeah, actually you can, I don't know why I did not substitute value here. Yeah, it can become 1, right? Cos 0, oh, sorry. If I substitute cos x equal to 0, it is 1. 1 minus 1 is 0, it is not defined. So I have to find the other way, correct? And that other way is nothing but cos 2x, I can write it as 2 cos square x minus 1, okay? So 2 cos square x minus 1 and minus 1. So 2 cos square x minus 2 divided by cos x minus 1, okay? Now I take cos x minus 1 common, okay? Cos x minus 1 if I take common, numerator and denominator I can cancel. I am left with limit extends to 0, 2 times cos x plus 1. Now I substitute 0 here, it will become 2 into 2, which is 4. Okay, next. Just I applied trigonometric rules basically, right? Okay, limit extends to 0, ax plus x cos x divided by b sin x. Okay, so same way you first split the numerator ax by b sin x plus x cos x by b sin x. Okay, now next step is apply limit for both the terms separately. Now 1 I have sin x by x and a by b. So this is 1. So this is a by b here. Second term x by tan x, it will become x by tan x also is 1. If limit extends to 0, x by tan x also 1, similar to x by sin x. Okay. And into 1 by b. So 1 by b is the answer. So a plus 1 divided by b is the final answer. Limit extends to 0, x secant x. Okay, x secant x is nothing but x by cos x. So cos 0 is not 0, right? Cos 0 is 1. So I can substitute. The answer is 0. Yeah. Limit extends to 0, sin ax plus bx divided by, I am doing the 20th question now. Sin ax plus bx divided by ax plus sin bx. Okay. So if I substitute x equal to 0, okay, 0 plus 0, 0, it is undefined in the direct method. So I am dividing this with ax, this with bx. I am adding ax by bx to nullify this effect. Okay, denominators, I mean divisions. Okay, now I take this ax into individual one. So it will become sin ax by ax plus b by a divided by a by b plus sin bx by bx into a by b. Now if I apply limit independently, this is 1, this is 1. So 1 plus b by a divided by a by b plus 1 into a by b. Okay, which is nothing but I get b by a into a by b, which is 1. Okay, do it carefully. These are all simple problems. Only thing is you will understand what kind of problems can come. Okay, next, limit extends to 0, cosecant x minus cot x. Okay, so both are undefined at x equal to 0, so you have to do in a different way. So I will write it as cosecant x as 1 by sin x minus cot x as cos x minus sin x. So it will become 1 minus cos x by sin x. I am multiplying both numerator and denominator with 1 plus cos x. Okay. So it will become 1 minus cos square x divided by sin x into 1 plus cos x. Okay. Now 1 minus cos square x is nothing but sin square x, right? Because sin square x plus cos square x equal to 1. Okay, now sin x and sin x I can cancel. So I am left with limit extends to 0, sin x by 1 plus cos x. Sin x by 1 plus cos x. Denominator is not 0, it will become 2, but numerator is 0, so answer is 0. 0 means it's not defined, limit is defined, limit value is 0. Okay. Limit extends to pi by 2, tan 2x by x minus pi by 2. So if I directly substitute, it is undefined. Okay. So what I will do is uh, tan 2x, I am writing it as tan 2x minus pi or pi minus 2x, or okay, minus, because this will give me minus basically. Okay, it is in, minus tan 2x, so minus of minus will become plus. Okay, and denominator I am writing it as 2x minus pi divided by 2. Okay, now I will rewrite this as, if x is tending to pi by 2, 2x minus pi will tend to 0. Okay, so minus 2 tan 2x minus pi divided by 2x minus pi, which is nothing but minus 2, and this value is 1. This value is 1. So minus 2 into 1, which is, sorry, it's not minus 1, it is minus 2 is the answer. Next. Find the limit extends to 0 f of x and limit extends to 1 f of x, where f of x is 2x plus 3 when x is less than or equal to 0, and f of x is 3 times x plus 1, x is greater than 0. Okay. So for such problems, we have done that before. You have to find out LHL and RHL. So limit extends to 0 minus f of 0 minus, basically f of 0 minus is uh, x is less than 0, slightly less than 0, which means I have to use 2x plus 3, which is 3. Okay. Here if I substitute x equal to 0, I'll get 3. Limit extends to 0 plus means x is greater than 0, which means I have to apply second one, 3 times x plus 1, which is nothing but 3. So LHL equal to RHL, which means limit is defined at x equal to x tends to 0, which is 3. Similarly, x tends to 1, what happens? In both cases, I have to apply only this value because x is closing to 1. 1 is always x is greater than 0. This one I have to apply, right? This function is defined 3 times x plus 1. So this is equal to 3 times x plus 1, which is 6. Next, find limit x tends to 1 f of x, where f of x is equal to x square minus 1 if x is less than or equal to 1, and it is minus x square minus 1 if x is greater than 0. Okay. So again, you have to find LHL and RHL at f of 1. So limit x tends to 1 minus means it is less than 1. Less than 1 means I have to take this value x square minus 1. Okay. Correct. So x square minus 1, which is nothing but 1 minus 1, that is 0. Limit extends to 1 plus. If it is 1 plus, sorry, this is not greater than 0, this is greater than 1 actually. Sorry. Okay. In this case, I have to take minus x square minus 1. So if I substitute 1 here, it will become minus 1 and minus 1, which is minus 2. In this case, LHL is not equal to RHL. Okay. Left hand limit is not equal to right hand limit. So limit does not exist at, is not defined at x equal to 1. Okay. Other one. Find limit x tends to 0 f of x, where f of x is absolute x by x, where x is not equal to 0, and f of x equal to 0 if it is x equal to 0. Okay. So let's find out. For LHL, limit x tends to 0 minus absolute x by x, because 0 minus, right? It is not equal to 0. So I have to take this value only, which is minus x by x, correct? Because x is negative. X is negative. Absolute x will become minus x by x, which is minus 1. Okay. Now limit x tends to 0 plus absolute x by x is nothing but, uh, I mean, in this case, x is positive, so absolute x is x by x, which is 1. Okay. So now my LHL is not equal to RHL. So it is not defined. Okay. Next. Yeah, find the limit x tends to 0 f of x, where f of x is x by absolute x, reverse basically, reverse of the previous question. Numerator and denominator are changed. I think you'll get same answer because when it is 0 minus and 0 plus, the absolute x is different. Absolute x is, in one case it is x, other case is minus x. So you will not get, limit is not defined. Okay. Next. Find limit x tends to 5 f of x, where f of x is equal to absolute x minus 5. Okay, there is no condition. So you just apply directly. F of x is nothing but 5 minus 5, which is 0. Okay, so limit value is 0. Okay. Suppose f of x equal to a plus bx for x is less than 1, and f of x equal to 4 for x equal to 1, f of x equal to b minus ax for. So there are three definitions of the function for x equal to x less than 1, x equal to 1, x greater than 1. Okay. And if the limit extends to 1, f of x equal to f of 1, which means they are telling limit is defined. Okay. Then what are the possible values of a and b? Okay. They are telling limit is defined. That means LHL is equal to RHL at x equal to 1. Okay. At x tends to 1 actually, not equal to 1. X tends to 1. Okay. So LHL equal to limit h tends to 0, f of 1 minus h. This is how you will write, right? When you say x tends to 0 minus or 1 minus basically. Okay. 1 minus h. Okay. Which means I have to take it is less than, 1 minus condition. Less than 1 condition means I will take a plus bx. So a plus b times x is nothing but 1 minus h. So I'll take 1 minus h. Okay. Minus of b, h minus 1. So this is same basically. Okay. Which is equal to f of 1. That's what is given. So which is 4. F of 1 is, f of 1 is 4. If you see, f of 1 is 4. Okay. So if I simplify this, I get h equal to 0, right? H equal to 0, if I substitute, I get a plus b equal to 4. Similarly, RHL, right hand limit, if I take limit h tends to 0, f of 1 plus h. Correct? H is very small value, 1 plus. Okay. Now it will become b minus, I have to take this one because it is more than 1, right? So b minus ax, so b minus a times 1 plus h is 0. If I substitute, then I get b minus a equal to 4. Now from these two equations, if I solve this, I get 2b equal to 8 or b equal to 4 and a equal to 0. So these are the a and b values. This is how we can solve the limit problems. Okay, next. Let a1, a2 up to an are fixed real numbers and defined as a function f of x equal to x minus a1 into x minus a2 up to x minus an. What is the limit x tends to a1 f of x? This is simple. There is no denominator for us. So you have to just straightforward substitute it. One of the term will become 0. So obviously it's a product of multiple terms. So it will become 0 only. Okay. So limit x tends to a f of x is equal to 0. Okay. And yeah, that's the only value. And if it is, I think I didn't write the question completely. There is also asked what is the limit extends to a f of x. Okay. So limit extends to a f of x is nothing but you replace x with a. So a minus a1, a minus a2 up to a minus an. That's it. Okay. This is simple definition. F of x equal to absolute x plus 1 for x less than 0, which is equal to 0 for f of x equal to 0 for x equal to 0, f of x equal to absolute x minus 1 for x greater than 0. For what values of a does limit extends to a f of x exists? Okay, so we need to check what values of a. Okay, so let's take case 1. A is less than 0. Let's assume a is less than 0. What happens? If a is less than 0, which function is there? The function is absolute x plus 1. So f of x equal to absolute x plus 1, which is nothing but because it is less than 0. Sorry, this will become minus x. Okay, this is for a greater than 0 condition. A greater than 0. Sorry, a less than 0. This will become minus x plus 1. Okay, let me correct it so that you understand what I'm trying to tell. This will become minus x plus 1. If you see f of x equal to minus x plus 1 is a straight line equation. Straight line is always continuous. There is no discontinuity, which means limit exists for all values. Okay, limit is continuous for all a is less than 0. Okay, limit exists. Similarly, this is the advantage of understanding the geometric methods, actually graphs. Actually, if you get a continuous graph, definitely you can say that limit exists for all the values. Okay, case 2 is a equal to 0. If a is equal to 0, f of x equal to, first limit extends to, I have to find out LHL and RHL, right? Because a equal to 0 is I need to find limit 0 minus a tends to 0 minus, which means I have to take this value absolute x plus 1, correct? So which is nothing but minus 0, right? Plus 1, which is 1. RHL, in terms of, in RHL case, it will become absolute x minus 1. So it will become minus 1. LHL is not equal to RHL, right? Left hand limit is one is plus 1, other one is minus 1. So limit does not exist for a equal to 0. What about a greater than 0? I think it should exist, right? So a greater than 0, if you take the f of x is nothing but absolute x minus 1. Okay. Again, this is plus. I made a mistake last time, right? Same. Plus 1. So this is also equation of a line which is continuous. So obviously, continuous graph. So limit will exist for a greater than 0. So limit is defined for a greater than 0, a less than 0, but not defined for a equal to 0. This is the answer. Okay. If the function f of x satisfies limit x tends to 1, f of x minus 2 divided by x square minus 1 equal to pi, evaluate limit x tends to 1 f of x. Okay. Yeah, this is a straightforward question. Okay. So limit x tends to 1, f of x minus 2 divided by x square minus 1. Now, if you substitute, denominator is 0, correct? That means limit is not defined unless until numerator also 0 at this value, x equal to x tends to 1, numerator also should become 0. That means you can cancel the uh, x minus 1 term from both numerator and denominator. For that one, numerator also should become 0, right? So substitute f of 1 minus 2 should be equal to 0. That means f of 1 is equal to 2. If f of 1 is nothing but limit x tends to 1 f of x, which is nothing but f of 1, that is 2, right? So this is how you should solve these problems. Next. If f of x equal to mx square plus n for x less than 0, nx plus m for x is between 0 and 1, and nx cube plus m for x greater than 1. Okay. Then what values of m and n does both the limits f of x and limit extends to 0 f of x and limit extends to 1 f of x exists? Okay, so it is given that both the limit extends to 0 f of x and limit extends to 1 f of x are defined, which means first find out LHL for limit extends to 0 minus, okay, which is nothing but f of x equal to 0 minus, right? So it should be, we should take mx square plus n, correct? So I will write it as h tends to 0, 0 minus h, and mh square plus n. Okay, now h is 0, if I substitute, it is n. RHL is similarly 0 plus, if I take 0 plus, okay, which means x is more than 0, which means this value, nx plus m is the value, correct? So limit h tends to 0, f of 0 plus h, which is nothing but nh plus m, correct? H is 0, so value is m. Now, since limit is defined for this one, limit extends to 0, these two values should be equal, correct? LHL should be equal to RHL, sorry. So many mistakes. Okay, RHL, which means m equal to n. This is my one condition, right? Second one, for limit extends to 1, again I will take limit extends to 1 minus f of x, which is nothing but limit h tends to 0, f of 1 minus h. Okay, since it is less than 1, I will take nx plus m. Okay, so in nx plus m, it is n times 1 minus h plus m. If I substitute h equal to 0, it will become n plus m. RHL also, if I do same, I get n plus m. So limit extends to 1 is true for all values. Okay, there is no condition required because it is whatever is the functions defined, they always give me for extends to 1, it is always n plus m only. Okay, so it is, there is no special condition for this. So both are equal and no new condition is required for limit extends to 1. So both limit exists for all m equal to n. If I take intersection of these two, if both limits are existing, then condition required is only m equal to n. If m equal to n, then both conditions satisfies, and limit extends to 0 and limit extends to 1 both exist. Okay. I hope you understand all these questions. Practice more. I will definitely start my shorts now on limits actually, because you will find wonderful questions from many entrance exams. Keep checking those, and some important formula I just formulated here, even though I did not mention some of them in this video. Whenever I do my next critical question videos, I will solve those formulae also. Okay. So these are the some of the them things. Trigonometric functions limits. This is I think limit extends to 0. Sin of x is straightforward. This is straightforward. This we have solved actually, which is equal to 0. This is important. Sin inverse of x by x also equal to 1. Okay, you can try to solve it yourself actually. Okay, and this is similar. Okay, we have solved these two, but these two also you can try to solve. Remember, it is very easy. Both sin and sin inverse of x by x, which is equal to 1. Okay. And these are the exponential and log functions of the limits. Okay, when we go into critical questions, right, I will explain these things more actually. So just remember them. A limit extends to 0, e power x equal to 1, which is straightforward, right? If you substitute e to the power of 0, which is 1. But in this case, it is 1. This you have to solve it. Let's do it out. Let's see later how to do this. Limit extends to infinity, 1 plus 1 by x whole power x is e. Okay, this is e power a. Then limit extends to 0, 1 plus x whole to the power of 1 by x is e. It is same actually, right? These two are same, right? Here it x tends to infinity, so 1 by x obviously tends to 0, correct? Which is same, okay? Limit extends to 0, a to the power of x minus 1 by x is log e, log a base e. And limit extends to 0, log of 1 plus x by x is, this is same as sin x by x actually, 1. Okay, so remember all these things. If you want to solve this, you can try L'Hospital rule and directly solve it actually. Let's say this one, if I want to solve it, okay, I apply L'Hospital rule, differentiate. E power x differentiation is e power x only. So e power x by 1. So x tends to 0, e power x, which is nothing but 1, correct? So this is how you can solve these things easily. Okay, some of the places you can easily apply L'Hospital. This also you can solve using L'Hospital rule. You can try it yourself. Okay. So Yeah, that's all the video. I covered only half of the chapter. Okay. My next chapter, I will again discuss about the derivatives of the same chapter. Okay. I will start my shorts on limits now. Keep checking those also. I will give the daily problems, all critical problems and PYQ based. I will cover all the PYQs. Okay. Thank you.